This is Unit 12, Day 2. In this video, we're going to be talking about area of trapezoids, kites, and related figures. So, on the earlier video, we ended a problem where we took a trapezoid, divided it into two triangles and a rectangle, and found the area that way. You don't have to do that every single time. We do actually have an equation for it, which is area equals 1/2 times the height times base 1 plus base 2. What you need to remember is that your two bases are your two parallel lines, okay? And then the height is going to be perpendicular to both of those bases. So if you look at the image to the right, that would imply that base 1 and base 2 are these two right here, because those are my two parallel lines. Okay, they only deal with the solid line again. And then the height has to be perpendicular to both my bases. So like this is the height. Usually it's drawn on the inside. It could be drawn on the outside, kind of like you see right there. So just a quick reminder, a trapezoid is exactly one pair of parallel sides. An isosceles trapezoid has congruent base angles and legs that will be coming up in a little bit. The height is always perpendicular to both bases, like I mentioned. Okay, so number one says the area of a trapezoid is 32 meters squared if the height is 4 meters and one of the bases is 6 meters. Find the length of the other base. So in this case, I already gave you the area. I want you to kind of go back and figure out a missing piece of information. So what I like to do is I like to just write out the equation. Area equals 1/2 times the height times base 1 plus base 2, and then fill in everything that I know. So it tells me the area is 32, so I replace that number. Equals 1/2 times, it tells me the height is 4, so I replace that number. And then one of my bases is 6, but I don't know what the other base is, so I'm going to leave that variable in there because apparently that's what we're trying to solve right now. Okay, so this is just where you use your algebra skills to simplify this. Personally, I would multiply this first. So 1/2 of 4 is 2 times 6 plus base 2. You can distribute the 2 at this point, or you can divide by 2. It is totally up to you. So that gives you 12 plus 2 times base 2. Subtract 12 from both sides. So 20 equals 2 times base 2. Divide both sides by 2. And then 10 meters is the length of base 2. Notice how it's not meters squared. This is just a measurement of a side. One-dimensional. I don't need to square anything unless it is the area. So take a look at number 2. I want you to find the area of that trapezoid. So if you notice, we're missing the height. But I do know that this is an isosceles trapezoid because those two sides are congruent. So once again, I'm going to draw in two heights and form this rectangle in the middle. So I know this length is 10. Well, that leaves 16 units for either side. Both of these triangles are congruent, which makes this length 8 and this length 8 as well. So once again, Pythagorean theorem is going to come into play so I can figure out what the height is. So this is h squared plus 8 squared equals 17 squared. Go through and do the math, or remember your triples. The height ends up equaling 15. So now that I know the height is 15, all I need to do is plug everything into my equation. So area equals 1/2 times the height, we said was 15, times base 1, which is 10, plus base 2, which is 26. So go back to that whole number. Don't be adding numbers together. Just go back to, we said it was 26 already. Multiply everything together. You should be getting 270 square inches. Now we're going to turn the page and talk about the area of a kite. And this actually also works for a rhombus, because if you remember, a rhombus was a special type of kite. So this time we're dealing with the diagonals. The diagonals, area equals 1/2 diagonal 1 times diagonal 2. 1/2 diagonal 1 times diagonal 2. So just remember, the diagonals are the ones that go all the way across from one vertex to another. So that would be D1. This guy over here, D2. Reminder, the diagonals of a rhombus and a kite are always perpendicular, and because they're perpendicular, Pythagorean theorem and special right triangles are definitely coming into play a lot with these types of shapes. So take a look at number 5. That's supposed to be a kite. Sorry, directions aren't clear. That's a kite, so I know all these angles in the middle are 90 degrees. Okay, and so what I want to do first is I want to figure out what the length of my diagonals are so I can use it in the equation. So I'm starting with this triangle, triangle 1 over here. This is a 45, 45, 90 triangle. I have the side across from 90 degrees. That is the L root 2 side. So if you remember, we divide by the square root of 2. That tells me my two legs are both 7 and 7. Also remember in a kite that the short diagonal is bisected. So that bottom length is also going to be 7 over here. So last thing we need to figure out then is the length of this part of the triangle to get the rest of my diagonal. So then I'm looking at this triangle 2 over here. I'm going to have to use Pythagorean theorem to figure out what the missing length is. So off to the side we're going to do 7 squared plus a squared equals 25 squared. Go through and solve, or remember your triples that a is going to somehow equal 24. Okay, so what that let me do is it let me figure out the lengths of my diagonals, so now I can just go through and plug them into my equation. Area equals 1/2 diagonal 1, so I add 7 plus 7, which is 14, times diagonal 2, so I add 7 plus 24, which is 31. Multiply everything together, and I get 217 square meters. So like I said in the video the other day, it's not hard to actually find the area. It's just trying to find all the key components that go into that equation is where the challenge will lie for most of us. Okay, number 6, the diagonals of a rhombus are 24 centimeters and 70 centimeters. Find the perimeter and the area of the rhombus. Well, good news for us, we can easily find the area already because it gave me both the diagonals. Area equals 1/2 times 24 times 70, and that should give you 840 square centimeters. Okay? The next part, a little bit more challenging, just because we have to find the side length of the rhombus right now. So if you want, I would sketch a rhombus off to the side just so you can kind of remember what this looks like. And we know we have our two diagonals drawn in. They're perpendicular. They also bisect each other. So with one of my diagonals being 24, I know this length is 12 and 12. With the other length being 70, I know this is 35 and 35. So because of that, if you look right here, I have a right triangle with two of my sides, and I just need to find the third side so I can find the side of the rhombus. So I'm going to do Pythagorean theorem again. 12 squared plus 35 squared equals c squared. Go through and solve it, or remember your triples that c equals 37. And then because it's a rhombus, all my sides are going to be the same. So that's going to be 37, that's 37, that's 37. So the perimeter is going to be 4 times 37, which is 148 centimeters, not square centimeters. Okay, it's only one direction that we're measuring. All right, 2 more. It says find the area of the kite. Find the area of the kite. So if you take a look at this, kite, we have one of my diagonals. I know one of the diagonals is 30, but I have no idea what this short diagonal is, and that's where we're kind of stuck. So what you want to look at is this right triangle right here. Okay, because what I did is I had a right triangle, and then I drew in the altitude. So this is our geometric mean property. The altitude squared equals part times part. Okay, so that's coming back into play. Altitude squared equals part times part. Leg squared equals part times whole could also be popping up. Anyways, 3 times 27 is 81. You take the square root. You get plus or minus 9 technically, but I only care about the positive 9 because the negative 9 doesn't make sense for us. And then I remember this was still a kite, which means a short diagonal gets bisected, so both of these are going to equal 9. From there, I got to find the area. So it's 1/2 diagonal 1, so 9 plus 9 is 18, times diagonal 2, 3 plus 27 is 30. So my total area is 270 meters squared. Okay. Number 8, the measure of the consecutive sides of a trapezoid are in ratio of 2 to 3 to 2 to 5. The perimeter of the trapezoid is 144 inches. Find the area. So kind of the key parts right here are the fact that I see a 2 and a 2, which implies to me that this has to be an isosceles trapezoid. So I'm going to draw it out so it kind of looks like that. There's my trapezoid, kind of. So I'm going to call this 2x, 3x, 2x, and 5x. And it tells me the perimeter is 144, so what I'm going to do is I'm going to add all that together, the 2x plus the 3x plus the 2x plus the 5x, and set that, whoops, that should say x, equals to 144. What you end up getting is 12x equals 144, and x should equal 12. So what I definitely want to do right now is I want to take that 12, plug it back in so I can figure out all my side lengths. 3 times 12 is 36. 2 times 12 is 24, so that's for here and here. And 5 times 12 is 60. So all I did was I took the number, plugged it back in for x. So then from there, it's a problem similar to what we had to solve in number 2, I believe, on the first page. It's an isosceles trapezoid. We need to find the height still, so I'm going to draw in 2 heights on either side, so I form this rectangle in the middle with this length right here as 36. So then if I do 60 minus 36, that gives me 24 to split evenly amongst those 2 triangles on either side. So that means this length has to be 12, and this length has to be 12. If you missed what I just said, I did 60 minus 36. That gave me 24, and then I divided it in half to get both those numbers right there. So then I'm looking at this, and oh, why did I write 12 right there? That should definitely say 24. Sorry about that. So I'm looking at this, and I still need to find my height. So I'm looking at this triangle on the right-hand side. That's a right triangle where I can use Pythagorean theorem to figure out the height. So that would be 12 squared plus h squared equals 24 squared. Now, unfortunately for us, this is not a triple, but there's another pattern. If you catch that'll make it a lot faster. For the rest of us, we're going to go through and solve those. So I end up getting h squared equals 432. I squared the 24, I squared the 12, I subtracted over. And then I have to take the square root of both sides. So this breaks down into 144 and 3. So the square root of 144 is 12 root 3. For those of you wondering what the shortcut was, this is a 30, 60, 90 triangle. Except the short side is 12, and then the hypotenuse was 2 times the short side, 24. So the side across from 60 will have to be the short side times the square root of 3, or 12 root 3. Now that I have the height, I'm going to plug everything into my area equation. So area equals 1/2 times the height times the sum of the 2 bases. So 36 plus 60. You go through and calculate everything out. You should be getting 576 root 3 square inches. Have fun solving.